Okay, so hello. Today in this video, we'll be covering practical implementation of random forest classifier basically with Python. So here I'm on a platform called Kaggle. So this is a very cool platform. It's just like Google Colab. So here you can run and test your machine learning model. Apart from that, you are also having some added functionalities like accelerators and all. And also you can input your data, and also you can search from the Kaggle's data set if you need any data set for your model selection purpose. So basically what we are doing in this tutorial is that we will be testing random forest classifier and seeing the performance of random forest classifier based on the change in number of the decision trees it contains and also some other hyperparameters. Okay, so in the first part of the video I'll be giving you some of the intuition about how it is working, and then we'll be just running the notebook and trying to see it practically. Okay, so without wasting much time, we'll be moving to the introduction of random forest. So obviously you all know that random forest is a bagging technique. Bagging technique. Okay, no need to mention that, and it uses what? Decision trees. Okay, so that's it for the introduction because we have already covered it. So next we can see that what is the intuition behind this random forest. Okay, so let's see. So basically what we have here in our hand, that we have some features, let's say f features. Okay, I'll take a good number, let's say that's an m feature. Okay, so assume that if you have a very big data set and this m is very large, so what will you end up with? You have f1, f2 and fm. Okay, so what will you end up with? That if you try to train your model with all the features in once, okay, you'll take and just put it in model. So what will happen? First thing comes that time complexity. Second thing comes is overfitting. How? Because let's assume that this is very large data set. Okay, so if you try to give this data set as whole to a single model, then what problem will occur? It will take a lot of time to train and learn features. And what about overfitting? Since you are giving the whole data at once, your model will try to learn the patterns and try to overfit, so that your model will not be generalized. If you consider a real life example, what will happen? That for example, next day you are having exam and you just try to mug up all the book in once, then what will happen? You'll obviously lose marks in the exam because you forgot what you have learned. Okay, and your brain crashes and whatever. So this is the same problem with the model. Okay, a model only tries to learn the best way possible in an efficient way. If you try to give it too much of data, too much of features, it will start getting confused, and that's what we don't want with a model. Okay, what about overfitting? In some case what will happen? It will start to learn too much of it even if it's not required, and it will try to learn the pattern. It's like you are learning a mathematical question. You are not understanding the mathematical question, you are learning a mathematical question. So this is what a real life example of overfitting and time complexity is. Okay, so what we can do to avoid this, we can break our data set. Okay, let's say f1, f2 and fn into row samples and feature samples that we have discussed. Okay, so now in this case what will happen? We'll be giving a permutation of combination of rows and features to the model, and this in turn will reduce first of all time complexity and overfitting. So now in random forest we have different decision trees. Okay, a different decision tree, number of decision trees basically, and each and every decision tree will be doing what? Learning some or other features. So in this case, not a single model will be overloaded. Okay, it will having a little amount of input and it will not be obviously overfitting. because we'll be trying to optimize it with reducing a max depth and using techniques like pruning and all. Okay. So this is the basic intuition behind random forest, that we do row sampling and feature sampling and use multiple models and parallels for testing, and after that we'll be taking, let's say 0 1 1 is the output, we'll be doing what in classification, we'll be taking majority voting. So this is the basic intuition of the random forest classification. Okay, now moving next, this is the very good diagrammatical representation of what I have just drawn. This is what happening is that we are having X data set, we divide it into N1, N2 and N3 and N4 features. Each and every tree will be learning some or other feature. Now we'll be classifying all the classes, and at the end we'll be doing majority voting and we'll get the final class. Okay, based on that. So this is how what we are doing, this feature sampling. So now your data set becomes small in terms of features, because if there are hundreds and thousands of features, let's say hundreds and thousands of features, and you'll try to give it to one model, then what will happen? It will obviously crash. Okay, and what you don't want. Okay, now next thing we can see is advantages and disadvantages of what we say, random forest algorithm. So okay, the advantage is obviously pretty much clear, that okay, it is basic, can be used for both classification and regression problem. Okay, and very robust model for large data set. I have showed you it doesn't suffer overfitting problem. Okay, because we take average or like majority voting of the outputs. Okay, and it can be also used for feature selection. Now this is very important. How feature selection? Let me just give you a quick intro. Okay, it's coming in the next section also, so I'll be moving it explaining you in that, but understand that this is very important. Feature selection is very important, because not every algorithm provides you with the facility of feature selection, but random forest does. And most of the bagging and boosting techniques, mostly bagging techniques, can be used for feature selection. Okay, now next is the disadvantages of random forest. The random forest is computationally expensive, because okay, we reduce the features by feature sampling, but the thing is there are too many decision trees. Okay, so what will happen in case of row sampling? There might be the case some of the data may get repeated and trained to multiple model. So this in turn, what will happen, then it will increase the complexity that you don't want. Okay, so this kind of case might occur in the this random forest. And the another thing is not very much technical, but it's for understanding purpose, that it is very difficult to assume and make intuition about this random forest, because random forest uses multiple decision trees. If you have single decision tree, then you can easily learn it and draw it, and okay, this is how the splitting is taking place. Here comes up your split, we ended up, or it is growing much more, so we pruned it. Okay, this is done. But in case of random forest, there are thousands of random decision trees, or even hundreds, or even tens. So there are lots of decision trees. So this will create a problem that it will be difficult to make an interpretation of what is happening internally. Okay, so next thing is what? Feature selection with random forest. So this I have told you, that random forest facilitates you with the feature of feature selection. So how it's happening? So let's say you have features F1, F2 and up to Fn. Okay, now what will happen in feature sampling? You will divide on the basis of features.